All right, a lecture to outline the differences between multi-AZ and read replicas. So in the exam, you're going to have so many questions asking you between the difference for multi-AZ and read replicas, and in which case you should choose one or the other. So you should know it by heart. Obviously, I'm going to repeat myself as what I said in the previous lectures, but it is super important for me to repeat myself because I really want you to know and master what is the difference between the two. And you'll see they're very different. So multi-AZ, we know exactly how that works already. Our application reads and writes to the master database, which lives in maybe AZA. And it turns out that this master database does synchronous replication to a standby database in another AZ. And that's going to be a standby instance. That instance, the standby, we cannot read and write from it at all. It is just there to do failover in case there's any problem with our master database. And our application, when it interfaces with our database, it talks to one DNS name. And the thing is, if one day failover happens, we will still talk to the same DNS name, and our application will talk to the other database. The standby will be promoted to being a master. So multi-AZ is not to scale read, it is just to increase fault tolerance. Now, in depth, basically, as I said, it's not used to support the reads, and you need to know when it fails over. It fails over only if the primary DB instance fails, there is an AZ outage, or the DB instance type is changed, so that you're doing some kind of maintenance. Another kind of maintenance you can be doing is also when the OS is going to do software patching, or when there is a manual failover by doing a reboot. And so when you do a reboot, the primary DB instance is not being usable, and so there's a failover that happens right away. There won't be any failover for long-running queries or deadlocks or database corruption errors, so watch out for those. And what you need to know is that the endpoint, as I said, the DNS endpoint, the URL, does not change after a failover. It is the exact same, and so your application should not have any change. They should just have some logic to reconnect to the database if they lose some connectivity. Now, why would we use multi-AZ on top of fault tolerance? Well, there are some questions which are asking, I want to lower the maintenance impact. So I want to basically make sure that whenever some maintenance happens, it takes less time. And so the idea is that you can use multi-AZ to reduce that maintenance, because if Amazon does some maintenance on your database, it will do it on the standby first. And when the standby has been upgraded, it will then be promoted to the master. And so you have much, much lower downtime than if you have a normal database without multi-AZ. Also, if you have backups in non-multi-AZ mode are done on the main database, but if you have a multi-AZ enabled, then the backups are created from the standby, and because nothing talks to the standby, then it won't impact the performance of the master database. And then finally, very good to know, multi-AZ is only within a single region, not cross-region. So if there is an entire region in AWS that goes down, then obviously it will impact your availability. So multi-AZ you need to master, and all of these should make sense to you, especially the last three: lower maintenance, backups from the standby. Basically, multi-AZ is used in this case to make sure that all the maintenance work does not happen on the main database and does not impact performance. But in no way it is used to improve the read performance. Now, for improving the read performance, we all know there is read replicas. And we've seen that diagram before. Read replicas means that your application still does the writes to a single master database instance, but for the reads, it can do it from any database that can be the master or the read replicas. What happens though is that the master to read replica replication is asynchronous. That means that it will happen eventually, but we don't know when. And usually very quick, but still there can be some consistency, obviously issues between the replicas and the master. And so the idea here is that our application using read replicas can scale the reads tremendously. So we know this, and you need to know that diagram, obviously. So read replicas help scale read traffic, and you can promote a read replica to be its own standalone database. So if you had a question around, hey, we want to have our own database that has the copy of the master database, and we want to have its own lifecycle for the database, then you can use a read replica for this. You can also create a replica within the same AZ, cross AZ, or even cross region. So it can be used to have some DR mechanism across region. Each read replica will have its own DNS endpoint, and so to scale or to load balance, you need to make sure that your applications are aware of all the read replicas DNS endpoints, and you can do read replicas of read replicas. And to make it even more complicated, read replicas can be multi-AZ. So the idea with read replicas is that they're just duplicates, right? Clones of your main database. The read replicas can help with DR or disaster recovery, as I said, only if you're using cross-region read replicas, because now you'll have a copy of your data asynchronously in another region. And good to know, read replicas are not supported for Oracle. And if a question at the exam asks you, hey, we want to run BI and analytics report on our production data, but we don't want to impact our production application, how should we do it? Well, you can make a read replica of it and then run your BI and analytics report and applications on top of your read replica. And you're for sure not going to impact your main database. So you need to know absolutely for the exam the difference between multi-AZ and read replicas by heart, and I hope I made this clear enough. So that's it for this lecture. I will see you in the next one.